Well, good evening, everybody. Thanks for coming out or checking in or signing in to this little presentation on the Great North American Eclipse, the second, coming soon to our skies. The background image, which you'll see periodically throughout the presentation, is actually from the 2017 eclipse as I saw it in Idaho. So what I'm going to be talking with you, presenting to you all this evening is a little history on eclipses in general, the general geometry of eclipses, how they happen, why they happen, and then I'm going to go through some safety information for you. That's probably the most important part of the presentation I have for you. And then details about the upcoming eclipse. And if you want to photograph it, I have a section in here about taking images of the eclipse before, during, and after, and a series of links that you could check out at your leisure. So, moving on. This is the path that the eclipse we're going to experience in a month from now is taking across the United States. It's coming up from Mexico, cutting through Texas, and then shooting up through the Ohio Valley and into the New England states before heading out to the northern Atlantic. Now, eclipses have been known for over 4,000 years. Before people understood the nature of the moon and Earth and the sun, eclipses were scary things because every day you woke up, the sun came up, the sun went across the sky, the sun went down, and periodically the moon would be you could see it in the daytime, you usually see it at night, you could see it sometimes in the early mornings in the daytime sky, but folks didn't really clue in that the moon was passing in front of the sun. And so whenever the sun vanished in their eyes, when an eclipse happened, they assigned all kinds of terrible things to this, portents of evil omens and failures of astrologers, who were the astronomers at the time, to predict these things. Usually, they didn't meet with happy endings. A lot of cultures, even some cultures today, will start banging pots or making a raucous noise to chase the evil spirit away that's currently eating the sun. Ancient Chinese used to think that a dragon was eating the sun, as did the cultures of India and Southeastern Asia and Peru. But amazingly, the Chinese, by 20 BC, they kind of figured out the actual nature of eclipses. The rest of the world was still thinking dragons. So this is the basic geometry of eclipses. When we have a lunar eclipse, which we have with fair regularity, this Earth is interposed between the moon and the sun in a direct line, such that the shadow of Earth falls on the moon, covering it up, hence the eclipse. When we have a solar eclipse, the Earth and the moon have inverted, and the moon is casting a shadow on Earth, much smaller because the moon is not near as large as Earth is. But the distance between Earth and the moon and Earth and the sun is such that sometimes the moon can appear the same, have the apparent size of the sun, thus cover it up completely. Now, if this were to happen, we have other issues, and we're not going to be worrying about any eclipses. So during a solar eclipse, you have this sort of orientation going on. The moon is casting a shadow in a small area on the Earth, but it's casting a broader shadow called the penumbra in a wider area. And that's generally where you're going to see the partial eclipse. The umbra, the dark shadow, which comes to a narrow area on Earth, the point of that triangle right there, I don't know if you can see my cursor, it's right here. That's called the umbra. And that's where you have totality, where the moon is covering the entire surface of the sun. So this is an illustration showing you the umbra, the penumbra, and as the moon is going across in its orbit, you can see the umbra is crossing across the surface of the Earth. So some fun facts about eclipses. A total solar eclipse occurs about every year and a half. The shortest time you can have between total solar eclipses is 12 months. There's 4 types of eclipses. There's a partial eclipse. There's an annular eclipse. There's a total eclipse. There's a hybrid, which is an annular/total. A partial eclipse is only when part of the sun is being covered up by the moon, and you're in basically what's known as the penumbra part. The sun is still super bright, that you don't see a shadow, but part of the sun is still covered. An annular eclipse is essentially a total eclipse, except that the moon is further away in its orbit from Earth at that point. So it actually appears to be smaller than the sun, and it does not completely cover the sun. So you have a ring around the moon. And this happened just late last year. Went through the western, southwestern states, was an annular eclipse. And I know of a handful of people had trekked out to see that. Total eclipse is when the moon is closer into Earth, because the moon's orbit is elliptical, not perfect circle, and it has the same or slightly larger apparent size as the sun, at which point when it covers the sun, it covers the entire surface of the sun. So you get to see the very ethereal corona out beyond the surface of the sun. A hybrid is when the moon is performing both an annular and a total. It starts out as an annular because of where it's at in its orbit, and as it's traversing across its orbit, it gets closer to us and becomes a total, and then it can then also finish up as an annular. The image in the lower left corner you see there is the end of a hybrid eclipse that occurred in 2013. It started out as an annular eclipse over Africa. As the moon's shadow crossed the Atlantic, it became a total. And then when it got to the United States, the moon was leaving the sun and was basically a partial eclipse for us at sunrise. So the Earth has a fairly large surface area of over 196 billion square miles. The maximum area, or the umbra, of an eclipsing moon only covers a little more than 21,000 square miles. That's about 0.1% of the Earth's surface that's covered by the moon. So it's a very small area at any one time would be covered by the moon's shadow. In 2024, which is, this year, a month and a day from now, the moon's shadow will be 123 miles across. In 2017, the eclipse there was about 50 or 60 miles across. So we're going to have a fatter shadow that the moon will be projecting onto the Earth. So we have more area where you can get into the path to see this. Now, due to the angle of the sun, of the moon's orbit around the sun, there can only be a maximum of 5 solar eclipses in a calendar year, and 4 of them have to be partial. If the moon were just a mere 273 kilometers smaller in diameter, it would never totally eclipse the sun. We would only see annular eclipses. And annular eclipses outnumber total eclipses on a scale of 5 to 4. Now, you've probably heard that the moon's orbit is slowly drifting away from Earth at, like a centimeter every 100 years or something like this. I don't remember the exact number, but in about 600 million years will be the last total solar eclipse that we'll be able to see from the surface of the Earth. So get it in now while you can. Now, the longest possible duration of a totality for solar eclipse is 7.5 minutes. The next time that happens will be June 13th in 2132. It'll be just under 7 minutes. In order to have a super long totality, it has to occur near the 4th of July when the Earth is furthest away from the sun. So the sun has the smallest apparent diameter in the sky. The moon has to be in what's known as perigee, or the closest point in its orbit to Earth. So it's the largest apparent diameter. It has to occur with the path close to the equator. so the slower speed of the lunar shadow relative to Earth's motion, and the sun has to be pretty much near true noon, true solar noon. So if you can hang out till 2132, then you'll get to have a nice long just under 7-minute eclipse, but I don't think most of us are going to make it quite that far. Now, this coming eclipse will be the last total solar eclipse that's visible in the United States until 2044. The 2044 eclipse will be visible from Montana and very northwestern North Dakota, otherwise mostly in Canada. There will be another eclipse that goes through the United States in 2045. But again, these are like 20 years from now. If you want to wait that long, and you can, great. I don't think I'm going to make it that long. If I do, yeah, great. Just to give you an idea of how rare eclipses are across any given area, I looked up some numbers. In Ohio, the last time Ohio had a total solar eclipse was in 1806. It will have this year a total solar eclipse, and the next one won't be until 2099. The last time Vermont had a total solar eclipse was 1932. The next time it will have a total solar eclipse after this will be 2106. So they don't come very often across one spot across the surface of the Earth. Now, before the eclipse in 2017, the post office came out with a stamp that if you rubbed it or heated it up, it would go from a total solar eclipse to an image of the moon, which is the center image you see here. And the very first photographed solar eclipse was done on July 28th in 1851 by a photographer named Johann Julius Friedrich Berkowski in Prussia. So the first detections of helium from the sun were made in 1868 by a French astronomer named Pierre-Jules César Hansen. He was doing a spectroscopic observation of the sun, and he noticed a signature line at what is the 587.49 nanometers, which corresponds to the helium line, which tells us that there's helium in the sun. Now, Einstein, you might recall, proposed the general theory of relativity back in 1915. 4 years later, there was a total solar eclipse in which he was able to demonstrate an aspect of the general theory of relativity, which is that gravity wells bend light. And to better understand the sun's influence on Earth's upper atmosphere, we've predicted that there are ionic or ionospheric bow waves that are created by the moon's shadow ahead of the eclipse. These were first actually observed from a satellite in space during the eclipse of 2017. So the 2024 eclipse, NASA has a number of experiments it's planning on doing, as are a number of other people, well, I would say around the world, but in some ways it is. First general imaging of the eclipse from 50,000 feet with a WB-57 high altitude research aircraft. It will get way up above most of Earth's atmosphere, so it will have very little atmospheric interference, and we'll be able to fly in the path of totality most of the time. There's going to be coronal observations, both imaging and spectroscopic, to learn more about the temperature and chemical composition of the corona and coronal mass ejections, which are shortened to CMEs. This will also be done from the WB-57 airplane. There's ionospheric experiments, which can affect radio communications, and ham radio operators across the world will be participating in this. It's called the Solar Eclipse QSO Party. There's going to be studies of impact of solar radiation or the absence of in the upper atmosphere. And there's going to be observations of active magnetic complex regions over the sunspots as the moon gradually covers them up. We are in a increasingly active period for the sun currently. So we should have a decent number of sunspots for these observations to be done in. Now, safety notes. If you take away anything from this, this is the section I hope you walk away with the most information on. Before totality and after totality, do not look at the sun with an unprotected eye. Even if you're 99% of the sun is covered, there's still enough sunlight that can cause retinal burns if you stare at it long enough. So the sun's out of eclipse, or during a partial, or during an annular, do not look at it without eye protection. The only time you can look at the sun during an eclipse without eye protection is at the time of totality. Do not use smoked film, X-ray film, stacks of sunglasses, or clouds to observe the sun before or after totality. They don't protect your eyes from the radiation that the sun's emitting and getting down here. There are things called eclipse glasses that you could look at the sun directly through, but do not look at them through a telescope. The telescope magnifies the power of the sun. And so you think the sun is bright with just looking at it with your unaided eye. You put a telescope on it, say magnified to 30 or 50 power, you're now looking at the sun at that much more strength, and it concentrates it to a much smaller area and will burn those glasses right off your face and your eyes too. Some telescopes come with sun filters for the eyepieces. When I was a young boy, my first telescope I got was a Kmart special telescope, a little 2.3-inch telescope, and it came with a sun filter for the eyepiece. And I did not know that that's actually a very dangerous thing. In the lower right corner is the light path that the light takes as it travels through the telescope and is then focused to that small area where the eyepiece is. As it's concentrating that light energy through there, it's also heating it, concentrating the heat and everything else. And those eyepiece filters can crack. And if it cracks while you're looking through it, you could instantly be blinded. I gave this talk a couple weeks ago to a camera club locally, and one gentleman said when he was younger, he also had this same type of eyepiece filter, and it cracked on him. He was able to look away just in time before the sun completely started pouring through that crack. So they're very dangerous. Now, ways you can safely observe the sun. You can make a pinhole shoebox or other type of pinhole projector. Basically, you take a box, you put a little pinhole prick in it, and put a white sheet of paper on the opposite side, and then you can aim it towards the sun, and you can see the sun projected on that sheet of paper. If you're in a wooded area or you got trees around, during the partial period, when the sun's only partially covered up, you can see the image of the sun on the ground through the leaves. The leaves act as multiple pinholes, and you can see the partial phase of the sun that way. You can also use interlaced fingers. You can use a colander. You can punch holes into a sheet of cardboard and get the exact same effect. So the bottom center image says totality 2017. This I did as my own experiment, just punched a bunch of holes in a sheet of cardboard and held it up during the partial phase. You could, if you have binoculars or a telescope, you can do projection, where you point your telescope or binoculars at the sun, have a tripod, don't look through them, but you can project the image of the sun on a screen behind the telescope or binoculars. The only danger here is if you keep the telescope or binoculars trained on the sun for an extended period of time, it will heat the optics up and could possibly damage them, and you won't be able to use them for anything else. Now, if you do the projection method, note that the two right images have a screen or a shield at the front end of the binocular or telescope. That's to give a shadow in the back so you can actually see the sun being projected onto the little screen. Other ways to safely observe the sun, solar glasses, eclipse glasses, they must have ISO 12312-2 on them. There are some that say 12312-2:2015, I believe, but it has to have the 12312-2 signature on there for ISO. Then it's safe to use to look directly at the sun. Now, if you have these eclipse glasses and you look at the sun, you're going to be surprised at how small it looks in the sky. It's not that big. Welder goggles rated at 14 or higher are safe to use to look at the sun also. And there are specially designed telescopes, such as the Coronado Personal Solar Telescope or the Lunt Solar Telescope. An example of the Coronado is in the lower center here. You can look directly at the sun with these telescopes, but you can look at nothing else because they have special filters on them that allow you to be able to look at the sun safely. However, these filters are built into the telescope itself, and you can see nothing else with it. You cannot see the moon, you cannot see stars, you cannot see the birds across the park with these things. They're super dense filters. And you can also get special solar filters to put on the front of your telescope or cameras or binoculars, such as the rightmost image here is a pair of binoculars with two solar filters made of mylar that are rubber banded to the front end of the binoculars. So you could look with those binoculars safely at the sun during the partial phase. During the totality phase, you'll want to take them off because you're not going to see anything otherwise. Now, this eclipse is a North Central and North American event only. It starts out in the Pacific, travels over to Mexico, cuts up through Mexico into the United States, and then up into the edge of Canada before drifting out into the Atlantic Ocean and concluding just before it reaches Europe. So here's the path of the total solar eclipse and the maximum duration of totality. As you can see, the closer you are to the Texas point, the longer totality will be. And this assumes you're at the center of that totality line. If you're off of the center of that path, and remember, it's 123 miles across, your totality period of time is going to be shorter. However, the closer you get, the longer your period of time. The eclipse is basically about a 4-minute long eclipse for most people who are going to be able to observe it from the center of the totality line. Now, some factoids. This is the second total solar eclipse that's touched U.S. soil since 1979, which was 44 years ago. Again, the umbral path was 123 miles at the widest. By the time it gets to Canada, it's 110 miles wide. If you're in Washington, D.C., when the eclipse happens, you're only going to see 87.4% of the sun covered. In Baltimore, it will be 88.2%. In Pittsburgh, I believe it's around 90 or 92% coverage. Or 90, no, it's 97% coverage. But again, 97% coverage, 99% coverage is not totality. You're only going to get a partial eclipse, even if it's just a sliver of the sun. You're not going to see the magic happen that happens at the center line. So the first total solar eclipse visible in Canada, this will be the first total solar eclipse visible in Canada since 1979. It's also the first total solar eclipse over Mexico since 1991. And here in the United States, it's crossing 14 states: Texas, Oklahoma, Arkansas, Missouri, Illinois, Kentucky, Indiana, Ohio, Michigan, Pennsylvania, New York, Vermont, New Hampshire, and Maine. The center line, as a bit of trivia, passed through Carbondale, Illinois back in 2017 and will pass through Carbondale, Illinois again this time. Expect a lot of people to hang out in Carbondale, Illinois for this eclipse. Now, again, the only time you can safely look at the sun without any eye protection is while you're in total eclipse. If you're taking photos, you want to take your filters off the cameras at that point. If you're using binoculars or telescope, you take the filters off. If you're using your eclipse glasses, take the filters, take them off, so you can see the ethereal magnificence of that you can only see during the eclipse, the totality. And during totality, you might want to take a moment, if you can tear your eyes away from what you're seeing in the sky, and notice the environment around you. The breeze will die down. Birds will stop chirping. Cows will turn and start heading for the barn. Crickets will start chirping. And the horizon will have a brightness to it as if it were sunrise or sunset, which it basically is. Everything else is thinking that night has fallen early and is acting accordingly. Bats will come out and start flying around looking for night insects. But this only lasts for a brief period of time, remember, just a few minutes. So the maximum totality of this eclipse is 4.5 minutes, and that will be near Nazas, Mexico. The sun's diameter is approximately 400 times larger than the moon, but also coincidentally, the sun is 400 times further away than the moon. So that's why it's basically the same size as the moon, or similar size as the moon. During the partial phase, especially as you're getting close to totality, you might be able to start picking out some of the planets that are near the sun. Jupiter and Venus should start popping out right near totality. And you might even be able to pick up Saturn, maybe even Mars. And possibly during totality, you might see the Pleiades. Now, there is also a comet running across the sky about this time, and no one trying to predict what comets are going to do is like herding a horde of cats into one room. It's very, very difficult to do. You may or may not be able to see a naked eye comet during totality. Just if you can find some star charts to show you where it's going to be during totality, that will give you an idea of where to look at that time. But you can also check various astronomy websites to see how bright that comet actually is right up before the day of totality. Now, this is going, if you're in the path of totality and you really, really, really want to be, it will be the quickest 3 to 4 minutes of your life. So you want to be flexible with the weather. Try and check the weather the day or night before. Remember, it's springtime in the United States, and many of you know what that means. If you need to go to the bathroom, do this at least 45 minutes before totality. Seriously, you don't want to be doing the pee dance during totality. And try to be considerate of everyone around you. Don't be playing music or shooting off fireworks, unless you go to an event that's sponsoring that sort of activity. For the most part, you're not going to be out there alone. If you're lucky, you'll be in an area with few people, but given the millions of people that live in the path of this eclipse and the millions who will be traveling to it, it's unlikely that you'll be alone. If you have a digital thermometer and you can set it up to track the temperature and make a graph out of it, you can see the temperature drop during totality. If you're in an elevated location, of which there are not many overly high along the eclipse shadow, if you can get up high, you can look in the distance before totality happens, you might be able to catch the moon shadow rushing at you. And it's coming very, very, very quickly. It's traveling at over 2,400 miles an hour. So if you see it, it will be a very short period before the totality hits you. Now, if you don't have a filter, like I mentioned earlier, you can make that pinhole camera to do a pre and post totality imaging. Now, this is just a stellarium view of what the sky looks like, or where the stars are and the constellations are during totality for next month. You can see where Venus and Saturn and Jupiter and some of the brighter stars will be relative to where the sun is. Now, a fun thing you can do is you can play with the shadows. As totality is approaching, as you get more and more of a sliver of the sun, as it's being covered up more, you can see a change in the shape of shadows. The light around you will also adopt a kind of a metallic gray silver tone to it. The shadows will be weird. In certain directions, they'll be blurry. In other directions, they'll be sharper. And this is primarily due to the increasing slit effect of the sun as the moon is covering more and more of it. So if you're traveling, if you don't actually live in the path of totality and you're traveling, you want to make sure you have everything you need ahead of time. So, checklists are a great thing to make, just to make sure you haven't forgotten something. And you want to bring some extra stuff. That includes food, water, and clothing. Because, again, there's going to be millions of people in the path of totality, millions of people traveling to the path of totality. And by millions, I'm talking tens to 100 million. So be prepared for places to not have food and snacks and running out of what we would normally take every day for granted. Bring a chair, hang out. It doesn't just happen in a period of minutes. It takes a while for the moon to cover the sun. So relax, enjoy the partial phase as it's happening. Using filters, you can watch it and see what phase the moon is covering the sun in, and look away, do something for a few minutes, look back, see how it's changed. As the moon is covering more and more of the sun, it will happen faster and faster. It will appear to happen faster and faster. So as you get closer to totality, you'll probably want to stop doing the extraneous things and just watch it happen. But in the meantime, if it's a sunny day and you're outside, you're going to be warm. So you want to shade any gear you have if you're doing photography. You may want to have a shade yourself, like find a tree or have an umbrella or something. If you're doing photography, most experienced eclipse people say don't take images of your first photo of your first total solar eclipse. Just go and experience it. However, there's people who will buck that conventional wisdom, and I am one of them. I did that in 2017. So if you want to take photos, practice ahead of time. Use the moon as a test target to test how your not your exposures, but how your camera's tracking, how it's focusing. If you're doing multiple. Hi, Tanya. I'm going to mute you, okay? Okay, thanks.
Sorry about that.
So practicing ahead of time will allow you to, when you get to where you're going for totality, to just set up and let everything happen. If you can automate your equipment, that's even better. A lot of cameras, especially nowadays, have automated functions, so you can just set it up and let it go, like time-lapse functionality. You can get star trackers that track the sun or the stars, and then clip your camera to that, so it will just follow the sun across the sky as the eclipse is happening and just take image after image and just accumulate. Once you've got that set up, you don't have to worry about your gear. You can just enjoy what's going on. If you're using new gear, again, do it long before the event. You don't want to be trying to figure out how to work your camera 2 minutes before totality happens. And you don't want to ask other people because they're going to be busy doing their thing with totality. And I mentioned filters earlier. Again, before totality, use your filters. But about up to 30 seconds before totality happens, you can take the filters off of your cameras and your telescopes and catch that moment when the diamond ring appears. And then you can see the Bailey beads. And then when totality fully takes hold, you'll see the corona. Again, automation, as I mentioned a moment ago, if you can automate your camera, your telescope or whatever, that's the best thing you can do. But in going on with automation, you want to turn off autofocus, because during the partial phase, your camera sees enough light from the sun to focus on it. But once the totality hits, there's not going to be that much light, and your camera is going to lose track of where the focus is. If you have autofocus on your camera and it's just doing its thing, you're not going to get a good photo of the totality. Now, you can choose to use a wide-angle lens, or you can use a telephoto lens for your camera. If you're using a wide-angle lens, you'll probably want to check out the landscape around you to see what's going to be in your field of view during totality. You also want to see how high the sun is going to be in the sky. And in April, early mid-afternoon, it's going to be fairly high in the sky. If you're using a telephoto lens, then basically you're zoomed in on the event itself and not worrying about the foreground or the dragons. Now, drones. If you're going to fly a drone, the best thing you can do is fly it super, super high above everyone so it's not bothering anyone. Otherwise, you're going to probably have a lot of disgruntled people around, and you know our culture in America, we'll shoot it down. They did that with the Chinese balloon. People tried to shoot that down. Again, if something goes wrong with your camera gear and stuff, just put it aside. That's not the time to try and fix it. It's going to take you longer to fix whatever went wrong than it is for the total eclipse to occur. But also, don't get so caught up in your gear that you forget to actually look at the total eclipse. Finally, just remember to take your filters off, because once it's all over, everyone who's taken their filters off, gotten their totality photos, are going to be cheering. And if you didn't, then you're going to have blankness on your film or digital film. So again, for you photography people out there, this is a very good site to check out, MrEclipse.com. He's one of several very good sites that you'll want to look into. Alan Dyer has a PDF that you can download called How to Photograph the Solar Eclipse. It's an amazing, thick book, PDF file, that's chock full of so much more than I have even alluded to in here. Again, MrEclipse.com is another wealth of information. And finally, Xavier Jubier has an exposure calculator, so you can calculate how long your exposure should be at what phase of the eclipse, given whatever ISO setting you have on your camera. So other things to look for during the eclipse, or right before, right after. About a minute before eclipse actually happens, you can see shadow bands on the ground. These are wavy, ethereal lines of light and dark. The best way to see them is to spread a large white sheet of paper or a sheet on the ground, nice and flat. And just as about a minute before totality hits, look down and check it out and see these shimmering shadows that are going across the paper. Some people have described them as like ethereal snakes that are slithering across the sheet. Others are like ripples or waves that are going across the sheet. 15 seconds before totality, you get the diamond ring. That's when the last bit of the surface of the sun is visible before the moon covers it up. And it only lasts for a few seconds. And it's an amazing sight to see. Then 5 seconds before totality happens, you get what's known as Bailey beads. These are little sections of the surface of the sun that are visible between the mountains and valleys on the edge of the moon. And as the moon starts covering things up more and more, you see the lower atmosphere of the sun. That's the reddish glow. That's the chromosphere. And it's only visible for a few seconds after totality sets in, and then the corona appears. It just glows across the sky. I don't know how else to describe it other than it's a magical moment during the total solar eclipse. And that is really the thing that gets most people. Once it's over and you've seen the experience, you've had the experience, celebrate. You've got to have this moment in time that you otherwise would not have gotten to experience. Record your thoughts if you want. Write them down, do a little recording, video recording or audio recording of your thoughts and impressions of the eclipse, what you experienced, what you saw, because memories will fade and slightly alter as the years go by, and it's going to be 20 years before we have another eclipse here in the United States. So, weather, again, springtime in America. There's a number of good weather sites that you could track up if you don't already have some that you regularly follow. This is a small list of those weather sites. So, springtime in America is notoriously cloudy. This is not to say any place along the path will not be clear. There is no 100% chance of clouds, but the further north you go along the eclipse path, the higher the percent chance that you will have cloudy skies during the eclipse. So here's a coarser breakdown of potential cloudy skies during the eclipse. If you're in Texas, you could have anywhere from 40 to 60% of the skies covered with clouds, which means you have 60 to 40% of the sky clear. And if the sun is right there in that patch, you get to see what you want to see. The same in Arkansas and Missouri and Illinois. Once you get to Indiana and pushing into Ohio, you start getting 60 to 70 and up into Ohio, 80% chance of the sky being covered with clouds. And here's an average cloud cover rating along the eclipse line for this time of April for each of these cities. Now, the next thing you'll have to deal with, traffic. There are millions of people who live along that eclipse line. There's millions of people who don't, and millions of people who will be traveling to get to the eclipse line. This is a watershed map showing the shortest distance for people to travel to get to the path of totality from where they live. That doesn't mean people are necessarily going to follow that watershed line, but if they're just going for the shortest drive time, this is the paths that they will take from where they're coming from. Now, this gives you an average time it will take to drive to totality. This does not take into account everyone else on the road. So if you're driving to the eclipse, try to make sure you have plenty of time to get to where you want to go, because the closer you are to the day of the eclipse, the more and more traffic there's going to be, especially if the eclipse is on a Monday. So that weekend is going to be a high traffic weekend. Also, while you're traveling, make sure you stay stocked up on gas as you go. Don't run it down to empty, get to a gas station, only find out that they've run out of gas because 10,000 other people have visited that same gas station before you. So this is by state a breakdown of how many people live along the totality line. So in New York, there's 3.7 million people live on the totality line. In Indiana, there's 3.9 million people live. Texas, over 12 million people live on the totality line. So already there's going to be millions of people in the totality line who are going to get to experience the eclipse. And there's likely to be that many people or more traveling to those areas to try and see the eclipse. So again, traffic post-eclipse is probably going to be a nightmare. Be prepared for that. during the 2017 eclipse, I know people sat trying to get through what were otherwise rural areas of Wyoming and Nebraska. For 10 to 12 hours, they were in traffic. I was in Idaho in the Sawtooth Mountains, and we got to see totality from there. And after it was over, we sat for a few hours, just let people go, get on the road, and we left later that afternoon. And by the time we got to where the traffic was, the traffic had already moved on. So we had a clear sail all the way back to Maryland. Just saying. Here's a close-up map of totality. And the lines there indicate the maximum duration of totality. The numbers are at the up in here, down in here, will tell you how long totality will be for those areas. This covers Texas and Arkansas and Missouri into Illinois, Indiana, Ohio, Pennsylvania, New York, Vermont, touching up to New Hampshire, Maine, and then up into Canada. You can get copies of these maps through greatamericaneclipse.com. They will take about a week or so for the order to get to you. So if you would like copies, and you can get the individual state groups maps, I would order soon. I ordered mine about a week and a half ago, and a week later, I just got them. So here are a number of links for you to carry on, check out. Lots of information here. The second link down, greatamericaneclipse.com. That's where I got the my eclipse maps. You can get eclipse glasses from there. And again, if you don't have eclipse glasses and you want to see this event, even if it's a partial, order them really, really, really soon, like by this weekend, because they're going fast and supplies are limited. There's, again, all these links are chock full of information for you. And finally, there's apps for the eclipse. Exploratorium has an eclipse app. The photographer's ephemeris, if you're doing photos of the eclipse, that's a invaluable resource to understand where you're going to be and what direction the sun is going to be at relative to where you're at, so you can predict how to set your camera up ahead of time. And eclipse.waas.org has a whole host of links of apps for eclipse simulators, planetarium programs, exposure calculators, camera controls for automating your eclipse imaging, and HDR imaging compositing. So finally, the best place in our solar system to see a total solar eclipse is right here. And I thank you all for coming and attending this. I will try to entertain questions now if you have them. Not sure how we're going to do this. Anyone have questions? Heather, go for it. Heather?
Okay, let's try this. So where are you going?
My plan is to be very flexible and mobile. I don't have reservations for anywhere. I know a lot of people have reservations for campgrounds along the eclipse path or staying at hotels or with friends. My plan is to travel to Western Tennessee. Unfortunately, due to work, we're leaving Friday after work, so we'll be joining the millions of people getting on the highway at that point. We're going to take a couple days to get to Western Tennessee, and then I'm going to check the weather and drive from there, either overnight or very early in the morning. The eclipse will be happening between 2 and 3 in the afternoon on Monday. Mandy.
I have a question about what you mentioned, the couple planets that will be visible, and you showed the star map, but could you perhaps talk about where in relation to the sun that some of these stars will be?
So the sun is going to be on this pink line right here.
Okay.
So that's the track that the sun will be taking across the sky. And it's going to be right in this area between Saturn and Jupiter. Let me go. So Saturn's here, Venus is here. This is where the sun is going to be, and Jupiter's up in this direction. So if you're looking at the total solar eclipse, off to the lower right, you'll see Venus, and upper left will be Jupiter. And those two should stand out pretty well.
Cool. Yeah, this is a great photo. Thank you.
Anybody else? I answered everyone's questions. Awesome. Well, then thanks everyone for coming out and sitting in on this. I hope you got some information out of it that you didn't know before, and I hope it helps with your decisions about going to the center line or where to go in the center line and how to observe the eclipse. I'm going to stop the recording now.
Mark,
Yes.
you said you would have difficulty distributing your talk. Could you just pull out the slides with reference listings?
Yes,
No.
I can.
Or
I
just
can.
like-
I can
and
distribute the slides
could be
themselves as a
small.
PDF file, not a problem.
Oh, okay.
The video is what I'm concerned about being able to
Oh,
distribute.
okay, never mind then.
But yeah, I can distribute I can send the slides out to people as they want them. And that will include everything you saw.
That sounds great.
Great. Awesome. Hi, Lucinda. How's Wyoming?
Hi, Indy. Hey, I gotta work. I was still in the Du Bois area and working for the Forest Service, and I got to work that 217 eclipse. Went straight over. It was fascinating.
Awesome.
Yeah, magical, fascinating, even though I was wearing my Forest Service uniform, and met the neatest people who had come to watch
That's
it.
great. Okay,
Yeah,
everyone.